Welcome to this explainer. Today, we're tackling a massive, often totally hidden challenge facing global construction and engineering projects. We're going to break down exactly how EPC buyers and importers can establish a rock-solid, structured qualification framework when sourcing ladder cable trays from China. Now, Chinese manufacturers are currently supplying EPC contractors in over 80 countries. It looks great on paper, right? But as you'll see, what's on paper doesn't always hold up in the field. So we're basically building a strict buyer's playbook today to help you separate the truly compliant suppliers from those who might be quietly cutting some major corners.
All right, here's our game plan. First, we'll uncover the hidden compliance trap. Second, the galvanizing bath problem, which is a big one. Third, our 5-criterion scorecard. Fourth, sourcing and documentation rules. And finally, we'll look at the ZINMA standard. Let's get right into it.
Section 1. The Hidden Compliance Trap. Now picture a massive 480 megawatt solar plant project. Huge stakes, right? They shortlisted 7 Chinese ladder cable tray suppliers. You'd think, hey, if you made the final 7 on a project of that scale, you are absolutely fully vetted. Well, no way. A shockingly high number, 3 out of those 7, actually failed a completely crucial final test.
Why? Because they literally could not produce traceable IEC 16537 load class certificates. That right there is the gold standard, folks. Turns out these suppliers were caught quoting to an undisclosed, much lower specification. They simply didn't have the paperwork to prove their trays could actually handle the physical loads required. Think about that for a second. If an EPC buyer hadn't rigorously checked for that exact traceable documentation, they would have literally installed structurally inferior components into a highly critical energy grid.
Moving on to Section 2, the galvanizing bath problem.
This is where things get really physical on the manufacturing floor. Imagine a galvanizing bath that's shorter than 6 meters. If you have a standard 6-meter tray, the manufacturer is forced to dip it twice. This double dipping creates incredibly dangerous coating inconsistencies, specifically right at the rail overlap zones. That is a guaranteed corrosion initiation point. It's basically a ticking time bomb for rust. But contrast that with a Guangdong supplier using a continuous 7.2-meter bath. Because the whole tray goes in at once, it delivers this beautiful, highly uniform 92 micrometer zinc coating. It's a night and day difference.
And the real-world payoff? It's huge. On a recent 500 kilovolt substation project, demanding that longer bath, and therefore avoiding those overlap flaws entirely, physically reduced their on-site rework by a massive 40 hours. I mean, that's 40 hours of highly expensive manual on-site labor completely saved just because someone understood the physical dimensions of their supplier's galvanizing bath.
Okay, Section 3, the 5-criterion scorecard. Look, you just cannot rely on a slick marketing brochure. You need a highly objective, 5-criterion weighted scorecard to rank these suppliers. And the absolute secret sauce here, you have to complete this scorecard prior to issuing your RFQs. If you wait until after, it's way too late. By applying this metric early, you slice right through the empty claims, separating the real players from the pretenders. It ensures that when you do issue that RFQ, every single quote you get back is apples to apples, based on identical, traceable specifications. Which brings us to Section 4, sourcing and documentation rules.
This is the part where you really have to define your supply chain. You've got to make a strategic call. When do you use direct factory sourcing versus going through a trading company? Direct sourcing? That gives you direct eyes on the factory floor. You know for a fact they have that 7.2-meter galvanizing bath. A trading company, though, might obscure exactly which factory is pouring your batch. And that kind of blind spot, that is exactly how those undisclosed lower specs we talked about earlier sneak right into your project.
But honestly, no matter who you buy from, your standard operating procedure absolutely must require specific documentation before the container is loaded. Not during, not after. Before. You have to verify those traceable IEC 61537 certificates, confirm the exact load class specs, and make 100% sure no one is quietly pushing a lower-grade product onto that ship. Because let's be real, the second those container doors swing shut, your leverage basically drops to zero.
All right, Section 5, the ZINMA standard. Let's look at what right actually looks like. So what does a fully compliant manufacturer look like in practice? Let's take ZINMA, Shanghai Shinema Busway and Cable Tray Company. These guys aren't just stamping out basic metal. They're engineering heavy-duty cable tray systems, busways, seismic bracing, and intelligent cable management. And they specifically target super demanding environments. We're talking massive data centers, rail transit networks, heavy industrial plants, the really intense stuff. And they're considered an industry benchmark for a very specific reason. Their products definitively comply with an incredibly strict suite of global standards. IEC 61537, NEMA VE1, BSEN 50085, and GB 31251. They don't just say they meet them, they have the paper trail to back it up. If you're an EPC buyer using that scorecard we talked about, seeing this kind of globally recognized documented compliance, it just entirely eliminates the guesswork.
So, armed with this whole playbook, the 5 criterion scorecard, the direct sourcing strategy, and knowing the literal pitfalls of a short galvanizing bath, you really have to ask yourself one critical question. Is your current supplier truly compliant? Like, are you absolutely 100% certain they aren't quietly quoting you some undisclosed lower specification right now? I highly challenge you. Take these exact criteria back to your current supply chain and demand to see that traceable documentation before your next container loads. Thanks for hanging out with me for this explainer, and keep asking those tough questions.